Hey, these are the solutions for problems from section 2.2. I'm going to break it up into two videos. I'm going to do 3 through 14 in one video because those are sort of a certain type, or a bunch of them are anyway. And then we'll break off. And I think these ones might take a little bit, especially once we get to, let's say, well, once we get to a certain point, they might take a little bit longer to talk about. Anyway, number 3. We're interested in finding what is the limit as x approaches 2 of x times x minus 1 times x plus 1. There's, first thing to say about this is there's no chance that this is going to be an indeterminate form because there's no denominator. So all I have to do is plug in 2 here. That's 2 times 2 minus 1 times 2 plus 1, which is 6. So this is just a plain old continuous function, some kind of cubic function, right? Because it's x times x times x. And it doesn't have any issues. There are no holes or jumps or vertical asymptotes or anything like that. So you just plug in 2 and you get your answer. Number 4. How about the limit as x approaches 3 of x cubed minus 3x squared plus 9x. I know your algebra instincts, you're just champing at the bit to factor that, but it's not necessary here because all we need to do is plug in 3 because there's no denominator, so there's no chance that there's any kind of issue here. So 3 cubed is 27 minus 3 times 3 squared is also 3 cubed, which is 27, plus 9 times 3 is also 27. So the answer is 27. Number 5. By the way, if you ever want to check, I tried as much as possible to assign odd-numbered problems because the answers are in the back of the book for you to check. But in the case where I do assign evens, I do have a solution manual in my classroom on my desk, which you are welcome to look at any time to check answers for even-numbered problems. So just ask about that if you need it, if there isn't a video for you to look at, like this one. So the limit as x approaches 3, x squared minus 2x over x plus 1. So we get excited here. Oh, maybe this is like a 0 over 0 limit, but it's not. If you plug 3 in the top, you get 3 squared, which is 9, minus 6 over 3 plus 1 is 4. So that's just 3/4. Nothing particularly interesting going on there. So why are they giving us these problems that aren't very interesting? I think just to make the point that not every single limit is a 0 over 0. In fact, 0 over 0 indeterminate form limits are going to be our bread and butter for a good while in Chapter 3. But not everything is like that, including this one. If you plug in 0, that term gets knocked out. Everything with an x turns into a 0, so it's just negative 9 over 3 or negative 3. And the other thing I think that emphasizes is that you always have, the first thing you need to do when you're trying to evaluate a limit is go ahead and plug in that number and see what you get. And then if you get 0 over 0, then more interesting things follow. So how about the limit as x approaches 1 from above of x to the 4th minus 1 over x minus 1? I plug in 1 to the top, that's 0, and the bottom 0. Here we go, there's 0 over 0. So now what? Well, if you know how to factor x to the 4th minus 1, then you can factor that. We can try to do the factor and cancel thing. And here, you should be able to factor that. I'm going to emphasize and insist, maybe to your great displeasure, that you need to, when you're writing out the work for these, you need to include this at every step. If you write the limit as x approaches 1 a positive of this, and then in this next step, you write just this without the limit. That's incorrect. That equal sign, the equal sign is a very, very powerful thing that is very easily, I think, abused and misused. If we're going to throw an equal sign here, then what follows here must actually be something that's equal to this, right? So if we want it to be equal, we need to include this qualifier. It's very, very important. Mathematics is the pursuit of everything that is true and beautiful. So we don't want to say anything that's not true or beautiful. I guess that's debatable what is beautiful or not. But so here again, I'm going to keep factoring this. Limit as x approaches 1 from the positive side. This is an exercise in discipline to write these things down. For those of you who don't like to show your work, it is not about showing work, it's about not writing things down that are false. I hope you can appreciate that difference. I'm not just forcing you to write things down because I think you have nothing better to do. I just don't want you to write things down that aren't true. Okay, so now that we have this, our goal when we do this factoring and canceling game is to get the thing that's causing the problem. The thing that's causing the problem as x approaches 1 is the x minus 1. This is the thing that's causing the 0 problem. Now I've got that to show up on the top and the bottom, so I can cancel that out. And now I can plug in my 1, and I get this is equal to 1 squared plus 1, which is 2, times 1 plus 1, which is 2, and that's equal to 4. If you're wondering why I didn't write that down again here, it's because once I have figured out what that problem is and got that to cancel out, that's the point where I can, that's the moment where I can plug in that 1 for the first time. So now I can definitively say that is equal to this. Right? And I didn't talk a whole lot about the factoring there, but this is the difference of two squares, right? X squared plus 1 times x squared minus 1, and then that again is the difference of two squares. So little things like that, algebra skills like factoring, come up all the time in the context of calculus problems where you really need to know those algebra skills. You need to remember them, or you will be left in the dust. So if you feel like you need to review any of that, let me know. I have plenty of materials that can help you out with that. All right, how about this one? What's the limit as x approaches negative 2? T cubed plus 8 over t plus 2. So the first thing we need to do is just make sure, check what kind of limit this is. When I plug in negative 2 here, negative 2 cubed is negative 8. Not positive 8, right, because there's 3 negative signs, so it retains the negative sign. Negative 8 plus 8 is 0, and on the bottom, negative 2 plus 2 is 0. So this is the 0 over 0, interesting type, and maybe I'll make the point here that it's never, ever okay to get 0 over 0 and say, oh, that means the limit does not exist. That's just not true. If you get 0 over 0, what that means is you have an indeterminate form, right? And I think I'm reiterating something from your notes here. Indeterminate means, just by your knowledge of word forms and their meanings, it cannot be determined, right? So when you get 0 over 0, it means there's more work to do. And here we need to do some factoring and canceling. Now, if you look at this on the top, t cubed plus 8, and you think to yourself, geez, once upon a time, I think maybe I knew how to factor the sum and difference of two cubes, but you can't remember here how to do it. You have an advantage here, and you don't actually have to remember how to factor this, because you know that negative 2 is making this equal to 0, which means that that t plus 2, this thing must be a factor of that. So I think the easiest, maybe slash best way to deal with that is to say, okay, I'm going to do some synthetic division here. I know that negative 2 must be a factor of this. Sorry, negative 2 is a 0 of that, right? And then be careful to put in the zeros in the right place. T cubed plus 8, that's 1, 0, 0, 8. Like so. You might have learned to do this with a little box going the other way, but it's all the same. That's my way of writing that. And so we drop the 1. Negative 2 times that is negative 2. I add these together. Negative 2 times negative 2 is 4. I get 4. Negative 2 times 4 is negative 8. And I get a 0 here. What if you didn't get a 0 here? What would that mean? Well, that means you messed up, right? Because we already plugged negative 2 in here and we got 0. So we know that we should get 0. We knew that, in fact, this is a factor of that. We just couldn't remember how to factor t cubed plus 8. But I don't need to now, because I know now that the other factor, the limit as t approaches negative 2, that this factors into t plus 2. Remember, this is the opposite sign of what it looks like when it's a factor, because negative 2 is the thing that makes this equal to 0. And then here, this gives me my coefficients, t squared minus 2t plus 4. And now I can cancel out the t plus 2's. And now I can plug in my negative 2. So this is the first step here where I can where I can skip writing the limit part, or it's appropriate to do that. So negative 2 squared is 4. Negative 2 times negative 2 plus 4, and then plus 4 is 12. And just one other little bit to say about that. In general, doing algebra, there's lots of algebra involved in calculus problems. We don't do a lot of algebra just for the sake of doing algebra. Algebra is a tool that we use to get to the bottom of all sorts of different calculus problems along the way. And I think I will say probably many times over the course of the year that you need to be careful that when you're factoring something like this, or say plugging negative 2 into this, you need to be careful. You need to be thoughtful and mind your signs, things like that. And if you think about what it means to be careful, it means you have to be full of care. You have to actually care about what you're doing, not just be going through the motions just so that you can be done with that problem and get on with the rest of your life. You have to care about what the result is and care about the steps that you're taking to get there, and the algebra and the rules of arithmetic and so on. And if you feel like really deep down in the core of your being that you don't care about things like that, then my advice to you is this. You can pretend that you care, and that goes actually a very long way to helping issues like sign mistakes and so on, just pretending that you care. But you do have to make some kind of effort. If you don't honestly, genuinely care, you got to try to pretend. Otherwise, there's just all sorts of careless mistakes that will be very difficult for you to avoid. So that's my advice for you there. Anyway, number 9. Limit as x approaches negative 1, 2x squared plus x minus 1 over x plus 1. So let's go ahead and plug in that negative 1 and see what happens. On the bottom, clearly going to get 0. On the top, when I square negative 1, I get positive 1. That's 2, minus 1, minus 1. So this is a 0 over 0. Now, you should be able to factor this without any trouble, I think, under any circumstances. But here, considering what we know, you've got a big advantage, because you know, since the negative 1 is causing this to be 0, you know that x plus 1 must be one of the factors, because if that top is also equal to 0, it means negative 1 is making it equal to 0, which means x plus 1 must be one of the factors. It cannot be otherwise. And if you know that that's one of the factors, I mean, when you're unfoiling something or factoring a trinomial like this, if you already know what one of the factors is, then the rest is just, I think, is very simple to do. So if we have a 2x squared here and an x here, then this has to be 2x, right? That's like the f of the FOIL. And then look at the last number. If this is a plus 1 and I end up with a negative 1 here, this must be minus 1. And you can check if you want, but that is the correct factorization of that. So it's a huge, huge advantage to know what one of the factors is. All right, so there's my problem, my 0 over 0, and cancel that out. And now I can plug the negative 1 in. So 2 times negative 1 is negative 2 minus 1 is negative 3. There's my answer. Number 10. At the limit, as x approaches 2, x squared minus 4x plus 4 over x squared plus x minus 6. All right, let's check out this 2 and see what happens. So 2 squared is 4, minus 4 times 2, that's minus 8 plus 4. So 4 minus 8 plus 4, that's 0 on the top, and on the bottom, 2 squared is 2 plus 2 minus 6, that's also 0. So it looks like I got to do some factoring and canceling again. But just like before, I know the 2 is making both of these equal to 0, top and bottom. So x minus 2. Hey, I want you to pause for a second here and look at your work. Did you write out this in front of the second step? It's necessary to have that there. If you don't have that there, then and you have an equal sign here connecting these two steps, then that's incorrect. Not because that's the way I want you to write it, because if you put an equal sign between these two things and this isn't there, it's not true. So watch out. All right, so I know that that has to be a factor of the top and the bottom, and that makes factoring very easy. So here, that's just an x squared, so that must be an x, and then the O of the FOIL, that's the minus 2 there. There must be a minus 2 here also. Minus 2 times minus 2. And if you just knew how to factor that looking at that, of course, that's super. I would expect that you did. And then here, this must be x plus 3. So even without that little advanced knowledge about x minus 2 being a factor, you probably could have factored those no problem. But it's nice to know that you have to have the x minus 2's. All right, x minus 2 is the thing that was causing the problem. Oh, which one should I have canceled out? Well, it doesn't matter. They're the same. Right? And now, when I plug the 2 in, I get 0 over 5. Is it a problem that I still have a 0? No, because 0 over 5 is just equal to 0. There's no kind of non-existence issue here, right? 0 over 0 is the indeterminate form. 0 over 5, 0 over a number, is just 0. All right? Number 11. Maybe as we're starting this one, I'll just give you a little bit of a maybe reminder, maybe you're hearing this for the first time, that the correct way, the proper way to use videos in this class when you're checking homework problems. For example, in this particular assignment, if you had trouble with this factoring business and you're looking at this video and you realize, oh, there's this whole synthetic division, or there's this sort of prior knowledge of what one of the factors is, and that's really helpful, then at that point in the video, you really should pause the video and go back and try to fix some of the mistakes that you made, or maybe some of the things that you couldn't figure out, instead of just sort of kicking back and watching the show. It's, I think, an abuse of watching solution videos if you just watch the whole thing eating a big bowl of popcorn and not engaging the video. Anytime you feel like you have an aha, like, oh, that makes sense, that's a point where you should pause the video and try to finish the problem yourself instead of just watching me do it. This is all about you learning how to do this stuff, not me doing this stuff. So please keep that in mind, and as best as you can, try to make that your practice using these videos. All right, so let's see what we have here. X approaching -1, so the bottom's equal to 0, and on the top I have 2 times -1, that's 2, minus 1, minus 1, so x plus 1 on the bottom. And didn't we just factor this? We did, it's right there, so we know x plus 1 must be a factor, 2x minus 1 is the other. So those cancel out. What's left when you cancel out everything from the bottom? When you're canceling things out, we're canceling out by multiplication and division. So that's not a 0 on the bottom. We're dividing that out. So there's a 1 left, that residual 1. So 1 left on the bottom. And then when I plug the -1 in here, I get -3. So did I just do the same problem 2 times in a row? Oh, I see what I did. Ha 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 ha. No wonder that one seemed familiar. I guess when I did number 9, I had accidentally done number 11. You probably already noticed that, didn't you? So sorry about that. That was number 11. So let's actually do number 9 over here. Sorry about that. So limit as x approaches -1 of x squared plus 6x plus 5 over x squared minus 3x minus 4. Those are 2 things you should be able to factor. You have plenty of good, solid algebra training. But in this case, when I plug in -1, 1 minus 6 plus 5, that's 0. 1 plus 3 minus 4, that's 0. We do have this advanced knowledge. Since I know that -1 makes both of these equal to 0, that means that x plus 1 must be a factor of that. And then the other factors are super easy to find from there. So that must be x minus 4. Those cancel. I plug in my -1, I get 4 over -5, or -4/5. All right, sorry for that confusion there. You probably weren't confused there. You just knew that I was making a mistake. All right, where are we now? Number 12. Got the limit as x approaches 1, 3x squared minus x minus 2. Many, many algebra students, past, present, probably future, live in mortal fear of having to factor things where there's a coefficient in front of the x squared. But you probably don't, because you're awesome algebra students. And besides, we don't really even need to worry about that, because when I plug in the 1, 3 minus 1 minus 2, that's a 0 on the top. So that means that x minus 1 must be a factor of that. And on the bottom, 1 plus 1 minus 3, x minus 1, it's got to be a factor of that. And that makes the factoring very, very easy, because if I'm going to multiply by x and get 3x squared, that has to be 3x. And if I'm multiplying here to get -2, that must be plus 2. And then here, on the bottom, 2x. And then if I'm multiplying by this and getting -3, that must be a plus 3. So there's no other way that that can happen. And if I plug 1 into this, now that I've got my problem go away, I have 5 over 5, which is 1. Number 13. 13 and 14, there's some cubic stuff going on here, and that's tricky. So I'm just going to say right now that this is the To factor the tops of these things, you have to use that synthetic division trick that I used back in, let's see, where was it? In number 8. So if you had trouble with 13 and 14, before you go any further and watch the show here, I want you to think about what I did in number 8, that synthetic division trick, and try that. All right, if you're back after trying that now, we'll go ahead and do number 13. And if it didn't work out for you, somehow you got stuck, then you can watch this one, but then you need to pause and try number 14, because that's how these videos work for you. I know how to do this stuff, because I've been doing it for many years. Not because I'm particularly smart or anything, but because I have been trained to be a calculus teacher, and I've been doing it for a long time. So I'm really, really good at calculus, and that is not particularly helpful to you unless you actually do the calculus yourself. So it's not the McGrath show here. It's about you. Let's see. So if I plug 2 into this, I get 8 plus 4 times plus 12, and then minus 24 plus 4. We're kind of expecting that it's going to be 0 over 0, and sure enough, 24 minus 24, that's 0 on the top. So before I do anything else, I know that if that's 0, if plugging 2 into this gives me 0, that means that t minus 2 must be a factor of that. And then on the bottom, this one's probably easy enough to factor. Maybe we'll just do that. You can plug in the 2, it's 8 minus 8, it's 0. But this is, you could factor out a t, which would leave t squared minus 4, and that's a difference of 2 squares, so that's t times t minus 2 times t plus 2. That's pretty easy factoring there. But you could still do a synthetic thing here if you wanted to. It would still work. Okay, the problem is here on the top, there are not any factoring methods. It's not like you can't remember what they are. There just are not any factoring methods that are going to work for this. Even factoring by grouping is not going to work here. So we do know that t minus 2 is a factor, which means that if I run 2 through my synthetic division here, my coefficients are 1, 3, negative 12, and 4. There weren't any terms missing, so I didn't need any zeros there. So I drop the 1. 2 times 1 is 2. Add 5. 2 times 5 is 10. Add negative 2. 2 times negative 2 is negative 4. Add. I get 0. If you don't get 0 here, it means you messed up. So here, the other factor must be t plus 5. T squared plus 5t minus 2. Now the problem, the thing that was causing the 0 over 0 problem, was the t minus 2. So we should be good now to plug in the 2. So 4 plus 10 minus 2 over 2 times 4 is 12 over 8, or 3/2. By the way, if I don't tell you this in class, none of these problems should have any calculator use involved at all. I guess that should be clear from the way that I'm doing them here, but you should be attempting all these without a calculator. If you learn some tricks along the way about how to factor things with a calculator, I mean, that's great, that's a thing, you can do that, but in a real situation, problem-solving situation for us, you would not have your calculator available to do problems like this. We'll talk about that more in class. All right, and then, so if that helped clarify things here, and you still didn't get that on your own, then pause before we do this, and you try number 14 on your own. Let's try plugging in the 1, see what happens. 1 plus 3 is 5 minus 5. That's a 0 on the top, which means that t minus 1 must be a factor of that. On the bottom, 1 plus 2 minus 3, what do you know? It's 0 over 0. That happens a lot for us, but be careful, don't just assume that. Okay, so let's see. Neither of these are things that I really know how to factor. Factoring by grouping isn't going to work, so I'm going to have to do my little synthetic division game here for both of these. So let's see. For this one on the top, I know that 1 got to work, and my coefficients here are 1, 1, negative 5, and 3. Drop the 1, multiply, add, multiply, add, multiply, add. Didn't get a 0 here? Means you messed up. Why does it mean we messed up? Because when you plugged 1 in here, we got 0. So that has to come out to be 0. So t squared plus 2t minus 3 on the top. And let's do that again for the bottom. Let's see, so again, 1, we know that that's making it equal to 0. Be careful here, we're missing a t squared term. So 1, 0, negative 3, 2. Be careful, being full of care, giving a crap about what you're doing. It's important. 1 times 1 is 1, add, multiply, add, multiply. Got a 0, didn't mess it up. So t squared plus t minus 2. Now if you look at these things, those can actually be factored also. So let's see what happens here. When I cancel those out and I plug in my 1, I get 1 plus 2 minus 3, that's a 0. And then on the bottom, 1 plus 1 minus 2, I got 0 over 0 again. So that means there's more work to be done. I got to factor again. But this time, those you might be able to factor more easily. And to boot, we know that that should be minus, t minus 1, once again, because I'm getting 0 over 0 again, t minus 1 must be a factor again of those two. Sorry for this mess here. Those are t minus 1s. So if t minus 1 is a factor of the top, then the other factor has to be t plus 3, right? And then here, another factor has to be t plus 2. So finally, plugging in 1, now that I've got rid of the 0 over 0 problem once and for all, I've got 4 over 3. And that's some factoring and canceling problems for evaluating, or that method where that applies for evaluating limits of indeterminate form 0 over 0.